Probably one of the smartest people you'll meet out here if you can get through his saucy British exterior. So, with much ado about nothing, Conrad Constantine.
Before I get into any of this, I mean, my whole point on putting this talk together is the last 5 years, I've been working on an idea. I want other people to go, this might be a good idea. Take it, run with it, and do something cool with it yourself. A couple of times I'm going to be diving into what I think, why this shit is important, why it's useful, and why it's practical. And I'm going to try and give you a few things on how you can actually go and do this stuff practically yourself. This morning's talk I did was all about skull and bones and scary crap, so I think I needed a little more flowery introduction for this one. Yeah, you gotta balance it all out. 2 years ago here, I did a talk called The Leverage of Language, how information theory might save information security. I've been working on this thing myself, personal project, so an open source framework I'm trying to make happen. But after talking to Rob, I realized I needed other people that were going to sit around and hack away on this tech themselves. This is that talk. I love this quote. We are information security people, yet we spend most of our time working with data, not information. In fact, most of us in our day jobs spend a lot of our time being human extract, transform, load engine agents. This is insane. Why do we spend all this time doing it? Because the things we actually come up with in terms of information, they're in our heads. We don't have a good formal way of encoding the information we create from the greatest pattern recognition engine on the planet, the human brain. Goes to experience. From my skills and experience, I think I have a hunch about this. This is why I got started with this. And I said, I want to be able to encode this. I want to be able to capture that kind of tribal knowledge. I don't want to have to keep explaining how to do stuff to the new kids in the business. A few other things. My first set was realizing that we're stuck in the SQL world. We do everything with CSV, SQL databases, all these structured data sets. But essentially they're all so fundamentally broken for the nature of how security works for us. And so 5 years ago, I started getting into this idea of looking for a better technology to handle security information, security data with. Next 40 minutes, I'm going to give you some of the basics on how to go out, hack with this stuff yourself. Up until about last 6 months, I thought I was the only person on the planet really messing with this. By all means, after I'm done here, get a hold of me, talk about this shit. The only reason I'm here today is to give some other folks the idea that this might be a good idea, play around with themselves, and give me some other people to talk to. Play with it themselves. Yeah, fuck you. Fuck you. Fuck you. And that's a good way to get a hold of me. And by the way, that's actually... Nope, I didn't fuck that up. That is actually correctly structured semantic information in the total format. Wow. I actually did something right. That's kind of a rarity. So, I've done years working in DFIR, incident response, incident management, a lot of various companies. Oh, the door's closed. Okay. I'm the motherfucker that discovered the RSA breach, by the way. And if you buy me enough beer, I will tell you all the shit that they didn't tell you in public. Working up to that point, and working all the systems that I was putting together to give them a fighting chance for that shit, is kind of the basis for where I am today. We were trying to work on things in terms of structured databases, tracking information, SIM systems, GRC. Everything I worked with was essentially It was a compromise. It was not a good compromise. I can talk about this for hours, but essentially I got to the point where I realized I was unhappy with every security product out there because they all wanted me to do my job in that security project. And I realized that my job is larger than any single control. The people I work with, the teams I manage, their job is larger than any single security control. I wanted to capture the information they were creating, the discoveries they were making, doing their job. And we just could not do that in fixated, structured databases. Disclaimer time. I think I already gave you this one. I got talked into doing this because I've been working on it for a while. I know this asshole. I know Meredith. I am not an academic. I do not have any kind of degree. But apparently, in the last couple of years of working on stuff practically, I found myself hanging around with these fuckers. Which is why, for some reason, I'm on this track right now with an audience full of people that are far more qualified to talk about this stuff than me. So, bear with me. I am going to get shit wrong. I'm not an academic. I am going to use the terms that I think work best and to help you understand how to make this stuff practical. Granted, in the last couple of years, terms like first-order transitive axioms have become things that have turned into my day-to-day vocabulary. This scares the hell out of me. But what I can do is I can give you all the stuff I've been working on, get past the weirdness of how to make this tech work, and if you guys use it and do something cool with it, this is totally worth my time, because this is the only thing I really want to do. I want to see other people working on the shit I'm working on. Let's say, so I've got someone else to compare notes with. That's fucking lonely. I got started, like everyone got started, RDBMS systems, relational databases. Unfortunately, you get to the point where you realize that for any relational database, to design it properly, to make full database closure, you have to understand the full scope of the medium you are describing ahead of time. We work in security. Every single day we wake up and the goalposts have changed. Making a database that describes what we do is impossible by definition. It changes all the time. I started looking for an excuse for some kind of way of describing data, tracking and recording the things we were working on that worked on this system from the ground up, that was happy with the idea that tomorrow the universe is going to change on you. So I got to this whole idea of semantic data, the semantic web. The first thing that appealed to me on it was that relationships are first-class concepts. Semantic data is based around relationships between entities, not the properties of those entities. Right here, relational databases. Every time you want to make a link to another table, another entity, you have to add another column, another foreign key. You have to build all that in. It is difficult. That was the first closing moment for me going, there has to be a better way. So I got into this idea of going semantic data, graph databases. Graph databases are all about relationships. The information is there, but the information is not what describes what we actually do. It is the relationships, the context between things that describes doing security work, doing security investigation. It is not anything on its own that is important. It is that thing in relationship to the other things around it. I look back and realize tables, taxonomies, hierarchical systems were all fundamentally broken with this. So I ended up coming across the semantic web, which was just created by a certain dude called Tim Berners-Lee. You might have heard of him. He created like HTML and shit like that. Semantic web never really caught on. There's a couple of things out there that sort of use it, but it's one of those technologies that's still waiting for a killer application. And when I started searching for something that actually represented what security work looks like, I come across the semantic web that still, to this day, nobody really uses. There are a couple of people, and I'll get into them later. But it looked like the right solution, or at least the least worst solution out of all the other available. The semantic web is based on a simple technology, RDF, Resource Descriptor Framework. It's ugly as hell. And if I do my job today, I'll help you all realize it's still ugly as hell, but you can still figure your way through it. Semantic web, ontologies, language-based information is all based on this idea of graph data. You see directed graphs where you have nodes and connections. It's incredibly simple. I'm sure damn near everyone in this building today has at least messed around with Maltego and a few other things. The stuff is out there, but it just does not go far enough. That's what I want to hope to encourage you all to do. The technology is really simple. No massive tables, no foreign keys, just the triple. Subject, predicate, object. Thing A is related to thing B. Thing A has property, this value. But once you start building off that simple basis of these SPO triples, you can start constructing some very complex stuff really simply. This IP address is a known bad IP. VeryTrustable.com owns the domain that IP is on, subnet that IP is on. This executable was installed on CEO Bob's PC. CEO Bob's PC connected to this shitty IP. You know what I like about this? This is a story. This isn't data. This isn't pulling shit out of a database table and running complex queries. This is a story of what happened on my network. This is the story of how our CEO downloaded that porn app and fucked the entire company in 4 lines. So what are these things? Once you start putting these triples together, you have to go, what is a thing? So we have subject, predicate, object. Subject and object, the left and the rightmost, are these things. Semantic data is very, very object-oriented. Things, not strings. This is a line I stole from Google because they have their own knowledge graph. And they come in 2 forms. There are nodes, which are locations, which are intended to be unique. And then there are literals. Literals are actual data values. I mean, when we put a database together, we expect it to be full of these literal actual data values. Most databases are mostly full of literals, and then a few relationships, foreign keys, to other tables. Now, a node itself, we're used to semantic web. The default version for these things is as HTTP URIs, but also URNs. They're intended to be globally unique. And they are intended to be deconstructable. There is, when we say some data thing A, there should be some content there, but it's not necessary, and I'll show you why later. Now, the other half of these things are the things we don't know. We know they exist, but we don't know what their name is. We don't have a proper name for them. These are called anonymous nodes. So for the subject and object, we have 2 nodes, named, identifiable, and anonymous. They are there, but we don't have something to call them. The intention with name nodes is that there should be some content there. There should be, the node describes something. Not necessary, though. For the semantic web, as Berners-Lee imagined, this is an actual web page. And the semantic web is a way to describe the relationships between content. We don't necessarily need this, but in terms of what we're looking at, this URI could actually be a specific URI from one of our security controls, an output, a report. This is something we have. Here is how to relate it to other things. your IDS system, your SIM, give it a node, identify it. This is what I'm looking at, but this is how it relates to other things. It doesn't necessarily matter, though, especially in terms of like getting into this and implementing it. For literals, so these actual values. Quickly, there are two versions. Plain are just described as straight language text. Plain text strings with a little appendage here for what language they're in. So I can describe something, add a label to it, and go, this is what it's labeled in English, this is what it's labeled in German. Then there are type languages, type literals that describe what the actual data type is. So here we have a regular string, a date timestamp, and here this is a positive integer. So it describes any rational number above 0. The predicates are the middle point. Subject, predicate, object. Thing A has relationship to thing B. The predicate is the has relationship part. 3 varieties. Object properties, data properties, I didn't mention this there, annotations, but they're not really that important right now. Object properties describe those links on the graph. When I have a node on the graph, another node on the graph, and a line linking them, that's an object property. A data property is when I have a node and a little bit of extra text describing it, that's a data property. Kind of simple, really. Disturbingly simple. If anyone here writes code, you should all be familiar with namespaces. Namespaces are exactly that. A prefix to indicate that no matter what the name we use, it is only unique within this namespace. So you and I can write the same kind of stuff. We can name things the same way, but as long as we have different namespaces, they are still globally unique. For how we do this in terms of actually writing this kind of information, prefix. Some data, RDF server, example column, some data. There we go. So whenever I use the prefix some data, I'm actually referring to that absolute canonical name. So when we get to a little example there, some data thing A translates out, we're expanding a canonical name from a relative name to a namespace. If anyone doesn't get that, come harass me later. So what we end up is, our actual data set is just a single table of 3 columns, subject, predicate, object. Each one of them is a location, or a literal. Thing A has relationship to thing B. Thing A has data property. I am a data property. This is actual valid semantic data. It's all written in RDF. It's all expanded out, so you have the absolute names of everything here. This is what the actual data looks like in practice when you're writing it. When you turn it into a nice graph object, here we go. That set there turns into this nice simple graph of here's thing A, thing I made, related to. But all of this is built out by adding a line at a time. We never have to go back and recreate things. We're just expanding out the world of the things we know. Redone with namespaces. Kind of straightforward. Isn't that a lot more readable? At the top, we have our prefixes, the RDF schema, the RDFS schema, our things namespace, and my schema, which is our example schema here. Much more readable. And this is the key to semantic data, is the things we write in the data are readable to us as humans. If you're writing good semantic data, it does not require extravagant queries to turn back into something that a human can make sense of. I've spent so much time teaching people how to do basic SQL queries as part of their job. The thing about semantic data is it is understandable by de facto. It should come out to readable words. So, used a couple of things here. Thing A, what the hell is thing A? Has relationship to. What does that actually mean? This is where we get to the point of, well, we actually have to create some schemas for this stuff. And these schemas are interesting because from a language point of view, they don't describe structure, they describe grammar. How do you actually create one of these things from the ground up? Yeah. Thing. There we go. All right. Writing a schema off the bat. Again, we define our namespaces, and then we start defining the things we are describing. So we start describing a thing. A thing has a type of, well, it's a class of object. The label, it's a thing. Put a quick comment on that. It's things. And we start defining this predicate is related to. It's an object property. When you're rendering this object property in the software you're creating, when you want to render this on screen, as a web page, as an app, it doesn't matter. When you want to put this on screen and explain it to the people that are using the data you are creating, the label is related to. This is kind of interesting. Like, the presentation is contained within the data. There is no data layer and no presentation layer. They're one and the same. Here's the important part, domain and range. This is how to actually build real ontologies. Excuse me. The domain is the left part, the subject. What does this relationship describe from? The range, the right part, what does this relationship describe to? Again, I went ahead of myself there. What's important with this is that the same triples that describe our data describe our schema. We're all used to writing SQL schemas, and you go and dump the database, and it starts out with a bunch of table creates. And once it's done the table creates, you start defining the data that goes into those. With semantic data, you can expand the schema as you go. You can dump data in, and then halfway down the file go, yeah, there's another relationship type here that I was not aware of previously. I am now going to define it. The data, the schema, the information, and the information about the information are indistinguishable. The actual language you do for describing these things, I've talked about RDF, but the current standard is something called OWL, Web Ontology Language, but WOL just didn't kind of run right. It's W3 standard. It is actually just another bunch of RDF data, and it, like we described, there is a bunch of triples describing what these things mean. What is an object property? Well, here are a bunch of triples that an object property is a type of property. An object property can connect a class to another class. So how to go build one? First, you start out with, what are the things we're actually describing? So I want to build an ontology about IP addresses. Well, for today's world, we're going to go, well, I have this thing called an IPv4 address. I also have this thing called an IP version 6 address. But then you go, well, these things are actually kind of the same thing. They're both subclasses of IP address. If I want to write a property that describes any IP address, then probably I want to include both of these things. And then you start thinking about it more and go, well, what is an IP address? An IP address is a thing within the set of an IP subnet. And you start describing the world more and more in more detail. And then once you have this first run of what are the things we're looking at, what are the elements we're trying to describe and record, then you go, what are the relationships? What are the possible interactions? Is on subnet. An IP address is on subnet of a subnet object. It doesn't get any easier. It all expands out from here. This is what ontology design is about. Along the way, you have to, of course, record some actual information. Yes, I have an IP address, but what is the actual value of this IP address? Is it 192.168.10.10? Personally, if any of you record IP addresses as plain text strings, I hate you all. You are the problem I face every day. IP addresses are 32-bit integers. So you can start describing the interactions, adding actual tags of information. So you can start building out this graph of here I have this information, here I have this data. But the information is the interactions, the relationships between them. This is where we get fun and academic. From here on out, you can start describing these things called cardinalities. I am not going to get into cardinalities here today. These things are complex as all get out. But it is simply stuff going, what are the limits of things in reality? An IP address has only one subnet it can belong on. There may be supernets, but it belongs to one subnet. A specific subnet has only one net mask. It can't have more than one net mask. An email address may have several people in the to fields, several people in the BCC and CCC fields, but it can only have one sender. And you start getting to these ideas of cardinalities. This idea that an IP address can be on one subnet, but it can be on multiple supernets. An email can only have one sender, but it may have multiple destinations. And you start thinking about the nature of reality of these things we work with day to day, the ontology of them, if you were. And by building this formal grammar of the relationships between them, you can start putting together a schema that describes the actual work we do. Then we had to transitive axioms. Yeah, this stuff makes my brain hurt. The fun thing about transitive axioms is you can start inferring things that don't exist in your data. So for everyone that works with SQL, I want you all to tell me how you make a foreign key reference to a row that does not exist. Now, you know it exists. You just haven't found it. And you want to record that I know that this row exists, and I know that this row I'm looking at is related to this row that does not exist. When I find it, I will put that row in the database. But I want that relationship to already exist. You cannot do that with RDBMS structured data because it assumes that the world is already known ahead of time before schema design. With semantic data, that's part and parcel. We can do these things called materializing transitive axioms. And the fact that that phrase comes up in my day-to-day vocabulary is the only reason I feel comfortable being here in front of you today. So we start defining the rules of reality, our reality, the things we know, the things we work on. And because of those, we can say, if I have these things here and these things here, I know that because of how they work, this other thing I don't know about must exist. This system's infected, this system's infected. They're both vulnerable to, this vulnerability, but there is no workable exploit for it. But they've both been compromised, everything else. So this exploit must exist, even though I don't know about it yet. Real simple example. Robert is your avuncular relative. And it's really simple. It's an easy property chain to describe. If someone has a parent, and that parent has a brother, and I know that Bob's my uncle, then I know that there is a parent there for me, and Robert has a sibling, and that sibling has a brother, because his name is Bob. We don't know who this person is, but we know he exists. We can infer that this is an entity in our data set because of the transitive axioms we have described. We have described semantically the nature of our data set. And so when things are missing in our data set, we can reason against them to show us the things we have not yet observed. Now, if any of you all do DFIR work, do security investigation, you know what this looks like. There are things you know exist, but you haven't seen them yet. So I had to write up some of this stuff. The easy thing is, most of it's plain text. There are a couple of formats. Fuck XML. N triples is kind of complex. Really, I like Turtle. As far as describing this stuff, Turtle's the best way. It works on URIs, but primarily it works on those namespaces, and they don't need to be resolvable yet. As far as getting, this is one of the toughest things as far as like actually hacking away with the stuff, is you see a URI and you think it must exist. It does not necessarily need to be. It's a reference to a URI. This is actually valid semantic data. Everyone knows VCARD, addresses. We have a bunch of prefixes set up. We describe our ontology. Then we start describing classes. Here's a VCARD. It's a type of class. Label is VCARD. A little quick comment. If you want to display this in your application, on your web page, whatever you're using, that's your little pop-up text. Where is it defined by? There's the official location. Not necessary, though. Here we got a property. Property has name. It describes the relationship between this class object, a VCARD, and the actual name for it. Who's the actual name attached to it? Again, defined by, label, etc., etc. You can do all this stuff via HTTP. You can actually put semantic data, RDF, up resolvable, retrievable HTTP locations. You don't need to do it, though, to start messing around with it. You can put it together in a single text file. It does need a base address. Again, doesn't need to resolvable. They are completely valid URIs. And in fact, you can actually use URNs, but I'm not going to cover that. They need to end in a slash or a hash sign. If it's a slash, they're individual files. If it's a hash sign, then it's HTML anchors. How to get actually like running around and building an ontology. Do it in Turtle. Seriously, you'll thank me. Build a header section. This stuff's kind of easy. Start defining the things you want to track. Build these classes. These are just like object-oriented code. These are the classes of things you are going to describe. The things you're going to describe are going to be instances of classes. Give them labels, give them comments, give them annotations. Annotations are, you've seen comment and label here, they're annotations. They're describing the schema, they're describing the data. They're not actually data themselves. Really, really simple, just describing a simple host and an Active Directory domain. A host is a class. It's a subclass of a thing, because everything is a thing. It's a host. A simple relationship, an object relationship. Nope, that's less. That's an Active Directory domain, Microsoft Active Directory. There we go. Object property, describing relationships between things. We touched on this before. Domains, left side, range. Only a host can be on a domain. And on the right side, the range, on domain can only refer to a domain. This is, again, a grammatical thing. You can't use the term on domain to describe anything other than the relationship between a host and a domain. It just does not make linguistic sense other than in that context. Data properties, simple, actual information, actual data. This one here, interesting, as I said, on terms of cardinality, it's also a functional property. Any host or any domain can only have one name. This functional property says that for any left side here, a host or a domain, there can only be one triple. Host has name, Bob CEO PC, can only exist once. It has a cardinality of 1. Let's build together a few named individuals. Again, valid data. We have a domain. we have two hosts here, and they're described as being members of this domain. That makes a simple graph, too. So, the tech's fun, but why actually InfoSec? Exactly this. I'm lazy and stupid. I am not a math guy. I kind of actually write code for a living right now, but that's going to end soon. But the one thing I can do is describe the stuff I do for a living in terms of plain language. And that's what got me started on this, is how do I take the things I know and talk about and encode them and share them with other people? And even if they don't know what I'm talking about, pass on the grammar for what I'm talking about so they can understand it in their own interpretation. Spent so much time working on in intelligence gathering, information sharing. Everyone has their own shitty schema of how they put together their CSV. And we get it, and like, thank you, FBI, here's a list of IP addresses. How do we actually use that? Again, we spend most of our time working as being human extract, transform, load engines. I want something that describes what I'm actually looking at, and I want the systems I'm working with to be able to understand that and use it. Because if you say APT, and I say really fucking old school hacking, I can describe the grammar that says they're actually talking about the same thing. These two things mean the same thing. And I want my data systems, I want my data set, I want the information I'm working with to be able to understand that. I spent a lot of time trying to figure out how to make the kids fresh out of college without the 10,000 hours effective. Like, my mission right now in security is lower the bar to effectiveness for folks getting into this field. When the president says, we're going to create 5,000 new cybersecurity professionals this year, I'm going, cool, why don't you create 5,000 new brain surgeons while you're at it? Because, that doesn't take any time whatsoever. You sit down, read a book, you're an expert. What I found is I've spent a lot of time looking over the shoulder of junior InfoSec analysts. And they'll be looking at something and they say, I know something's going on here, but I can't figure out why. Can you take a look at this? And I'll say, I'm like, you know what? If you look over here, like, check out the systems from check out logs from this DNS server or this web server or something. I bet you are going to find something there that references what you're looking at right now. And they go, look at logs from the DNS server, and they see a resolution lookup, and then they go, oh, you're right, we shouldn't take the DNS server for the entire company offline for being infected with malware, because it's not actually connecting to the CNC system, it's just resolving the name for the CNC system. Not kidding, I've seen that happen too many times. And they're like, that's amazing. Okay, so from what I'm looking at right now, so I don't have to waste your time later, what in the alert I'm working on right now tells me to go look over that? I have to look at it and go, not a goddamn thing. I knew to look over there because, unlike you, I worked on a shit ton of system administration work and programming and all the other shit you need to do security work, because this is the reason the cops don't hire folks fresh out of the academy to go work on homicide. They need the time on the streets. They need that 10,000 hours. But I also realized that's not right. We have to fix that. If these kids had the context of that, I mean, once I showed them to it, it was like, that makes total sense now. Now I understand what I'm looking at. I'm sitting there going, why doesn't the system show you that? That's what got me into the whole semantic data thing. The idea that we can encode our experience in a fairly natural language format, make it machine processable, machine learnable, machine reasonable, but essentially the key thing is giving context to the folks doing the job at the entry level. You know what? I already talked about this. The whole cyber kill chain thing, this is the new hotness, has been for a couple of years. we do a bunch of hiring kids out of college and putting them in front of what's essentially a tech support queue. Security work is not tech support. It is not demand-driven. It is discovery-driven. What we do is more like bug hunting and quality assurance. And it is not the individual element that is important. It is the relationships between those elements that is important. That is how you do detective work. And more specifically, it's not about connecting the dots. A lot of times it's about finding the dots. So what's some actual useful tech to work on this? Hopefully you're all going, I want to like muck around with this because it sounds fun, maybe. I don't know. The first thing you need to know is text files. That's great, but I want an actual equivalent of a server. The stuff you're looking for is called a triple store. Allegro graph is kind of the de facto current. I really like Sesame. It takes 5 minutes to install. It is just a simple WAR archive for, I can't remember, the Apache Java thingy. Apache Jana is kind of kick-ass, does a whole bunch of stuff. 4store, really nice, Linux-based, all command line, wonderful to get into. What these things all do is produce a SPARQL endpoint. I've talked about creating data. Really, what the hell is the point in creating data if you can't query it? The language you're looking at is called SPARQL. Yes, there is an implementation of this called SPARQL Motion. Has anyone seen that movie? Yep, no, that is a thing. Really stupidly simple. You really only need three major iterators of syntax. Select, construct, and ask. Select is bring me the triples back. Construct is select from as, where you can build your own output. Ask is just a simple true or false, does this exist? Describe is kind of a bastard because it describes the things that define the stuff you're looking at. We've looked at ontologies. Hope the idea that these neighboring items are what's important. It's not the stuff I'm looking at, but it's what is connected to the things I'm looking at that is important, the context. Describe is intended to be, show me the context for the things I'm searching for. The syntax, really not that tough. A little less brain dead than SQL, I like to think. Simple select for one column worth. Construct allows us to construct our own triples that we can then dump back into the data store. Ask is just a simple true or false. Does this thing, according to my filter selection, exist? As far as getting into this stuff, I like Neon Toolkit. I don't trust its output. Protege is this huge Java app. It works really well, but it is obtuse as all hell to get into. There is a nice simple Notepad-style RDF editor for Windows written in .NET. .NET RDF, if C# is your thing, and I won't hold it against you because I've written a whole crap ton of stuff in C#, worth getting into. Top rate's kind of commercial. Obviously, you can start getting into stuff with just a text editor, but you need something to validate it. I write shit in Python for a living. That's actually kind of my day job, working on semantic data. I'm going to say right now, most of the stuff out there sucks. These are the least sucky ones. If you've mucked around with Django, Cubic Web is kind of fun. Cubic Web is kind of like Django as an MVC framework, but it works entirely as an ORM for semantic data instead of RDBMS. If you're one of those horrible people that really thinks that Java is good, you are a lucky bastard because most of the good shit for this stuff is actually written in Java. Owl API for doing reasoning, ontologies, all up there. Protege, Hermit. Hermit's a good reasoner, works with command line. Apache Jana, written in Java. So is Allegro Graph. These are the major players. I hate my life. You're going to want to start out with looking for some of the key standard ontologies and schemas to give you like how to work out with. You've seen that RDF schema, these are just triples. as I keep hammering down, the things that define the information are the information themselves. This is the key point of power. I have like 3 hours of material on why this stuff is actually important to security. All I want to do right now is get people interested in mucking around and taking it themselves. Great data set, Wikipedia, DBpedia, all semantic data, massive amount of data set of this thing is a thing, is related to this, has these properties, these cardinalities. As far as getting into this stuff, you really can't like get easy access to a larger data set. But there are no good security ontologies. There are a couple of terrible ones that are very managerial based and kind of like CV and everything, but they're not based on the core atomic level of stuff we deal with in our day-to-day work. But you know what? If the job I'm working on currently works out, then we might have a couple published in a while. That's another story. We want to be able to have a data set that we can run reasoning against, to individually crowd swarm the damn thing, record the stuff we know, that record the things we see, and then machine learn, process, reason over them to show us the things that we are either too clueless or too drunk to remember. Leave no stone unturned. And you know what? If you all come up with your own ontologies, it doesn't matter. The whole thing about semantic data is if you describe your view of the world and you tell me where I can find that view of the world, then I can use my information, I can use your information, and I can say, okay, what you describe as APT, I describe as old school hacking. But we know we're talking about the same thing because we've shared our grammars. We can describe what is different between them, what is common, and we can use our own view of the world, but still share information, talk with other people, and see what they're describing, what they're recording, without having to sit there and write another goddamn Python parser to take a CSV file and dump it into our database. There are no good security tools doing this today. You all probably know Maltego. Maltego is not even scratching the surface. I've spent the last couple of years working on my own framework. That's another talk. It ain't ready yet. The important thing is, and I think a lot of other people, are sick of having to explain the things we did years ago to other people time and again. I want to put the stuff I know in with the data I'm working on. So when you look at an IP address, when you look at a host in your workflow systems, when you're doing your job, the things I know about it not only are recorded and annotated there, but the interactions, the things that are possible, the things that are reality, the things that are ontology, are there for them to use. Because when you can describe what is real, when you have eliminated the impossible, whatever remains, no matter how improbable, must be the truth. This shit's confusing as fuck. It took me a while to get into it. Imagine if SQL was defined in SQL, and all you needed to do to understand SQL was read a bunch of SQL scripts. Welcome to Semantic Data. As I said, until recently, I thought I was the only person running on this. I'm at CP Constantine on Twitter, Conrad at Mercenary Logic. This is my current obsession with making happen. I want more people dicking around with this shit and going, I found something cool. I'm like, I had not thought of that before. You're quite correct. I think it's a good idea. It came out of me being just incredibly dissatisfied with the tech we had, and the more I got into it, the more possibility for things we hadn't even thought possible became possible. I'm just one guy. I need some other folks. go tinker around with this shit, and if it doesn't make sense to you, I'll be happy to go, it confuses the hell out of me too. Yeah, it'll be up on Dropbox, and I'll definitely publish this one. Like I say, this is one that, for what it's worth, the current job I'm working on, I was at the Pentagon about a month ago where I got detained by the head of counterintelligence, by DARPA. I knew that the intelligence community had been working on this stuff for a while as a decision support system and many other things. I knew that all I was doing was recreating work that had been done before behind closed doors 20 years ago. In the last 6 months, because I'm now sort of working on this DARPA contract, I've been meeting a lot of those people. I just ran into the guy who created DAML, DARPA markup language, which was the forerunner to OWL and a lot of other things. And I know all I'm doing is clean room re-engineering stuff that the intelligence community, the government, has had at their disposal for years. All I care about is getting some of those ideas, putting them in your hands, and going, can we come up with something cool with it? I think it's possible. That's my whole fucking talk, basically.